So today we're going to be looking at 5.2, and we're going to be looking at some new information here about circles. We're going to look at some definitions of what a central angle is and the arc of a circle. We're going to look at that kind of stuff here real quick and make some connections between them and see where that leads us. So a central angle, if you don't remember this from your geometry days, is an angle with the vertex at the center of a circle, and the sides of the angle are radii of the circle. So theta, theta, if you do not know that name, that is what that symbol is. It's kind of like a fancy O with a line through the middle, like so, is termed theta. And we use that for our basic, it's like our X for angles. The arc of a circle is the part of the circle that is intercepted by a central angle. So that would be what S is. So this is the arc that is cut from the circle by the central angle. So that is the arc. And so what we're going to do is we're going to make a connection between the central angle and this length of this arc that it is creating. And to do that, we need to look at, well, the arc is just simply part of the circumference of a circle. Okay, so let's make some connections here. If it's part of a circumference, then we need to look at the circumference of a circle. And let's put it right here. So the circumference of a circle is pi times the diameter, but we have radii here, so let's look at it as 2 pi times r. So the diameter is 2 radiuses, or radii, times pi, and we usually write it in this fashion right here, and it'll actually help us out and make more sense a little bit later. All right, so we're going to look at this. We have an angle here that is 30 degrees, and we're going to go through a process here, and we're going to make it very simple. We're going to make all the radius of these things a 1. So if the radius is 1, it makes our life a little bit easier. And when I make the radius 1 by this formula, then all the circumferences will be 2 pi for a circle. And so these are all kind of set the same all the way down. Okay? So the ratio of the circle. So 30 degrees, and 1 complete revolution of a circle is 360 degrees. So I have 30 degrees out of 360 degrees. And then we can reduce this down and get 1 out of 12. So what this is telling me is I have 1/12 of all the angles in the circle. So if I go all the way around the circle 1 time, 360 degrees, I'm going to produce the entire circumference. So if I only go 1/12, then I'm going to be doing 1/12 of the circumference. So we can take the circumference length and figure out what 1/12 of that is. And so then we can figure out the length of this arc right here as being pi over 6. So that is a length of that arc that is measured from the 30-degree angle. Okay? And this is on a circumference with a circle with a radius of 1. All right? And we can continue this process all the way down very quickly. This is 45 out of 360. And so you can reduce this down, and I do believe it is going to be, I can't remember anymore, 1/8. You reduce that, and so 2 pi times 1/8 gives me pi divided by 4. Okay, and we can go through the same process for all of these. This would be 1/6, and 2 pi times 1/6 is pi over 3. The 90-degree one, 90 over 360 is 1/4 of the circle, and so 1/4 of the circumference is pi over 2. And I'm just going to keep on going so we can get all these real quickly. 180 out of 360 is 1/2, and so half of that will be pi. And then we'll do the 270 And we can see that that's going to be 3/4 of the entire circle. And so 3/4 of 2 pi is 3 pi divided by 2. Okay, so we have all those. And then there's one more on the next page. And same thing here, 2 pi. And 360 degrees is 1. And so this is 2 pi times 1, or 2 pi. So that makes these connections between a central angle in degrees to an arc length of the circle circumference. Okay? And so that's the connection we kind of can make here between a central angle measurement to a measurement on the arc. This leads to the definition of a new measurement for angles called the radian measure. So we currently, at this point, only have had degrees. So now we're going to define what's called a radian. A radian is an angle measurement where the central angle of a circle intercepts an arc that is equal in length to the radius of the circle. So when the central angle creates an arc length that is exactly the same as the radius in length, then this angle is considered to be 1 radian. Okay? And so let's make some connections here, what we're talking about and all this kind of stuff. So we can now look at a measurement here in a radian format. And we can take this right here. If this right here angle measures 1 radian, I can continue this process and I can cut this into 6 wedges. You'll see why here in just a moment. And then we have one here. And then we have one here. And then what's going to happen here is you're going to have, it's a little bit off, but it's kind of hard to draw sometimes. So this is 1, 2, 3, 4, 5, and it's supposed to be 6, the same size. Okay? And then this would be, if I went straight across the circle right here, that would be the diameter. Okay? And so what I want you to see here, I did that one. That's why it's off, because I'm off a little bit. Let me fix some of this real quick. This one is going to be right about there. And this one will be right about here. And then these two like so. Anyway, so halfway across the circle, as we found over here, 180 degrees, is going to give an arc length that is pi. One time around the circle will give an arc length that is 2 pi. And so this mark right here is pi. And this mark over here is 2 pi. And then what I want you to see is the connection between those numbers that you know, because we know pi is approximately 3.1415 and so on. And then 2 pi is basically twice that. So approximately 6.28. And so if this is 1 radian, and that's 2 radians, and that's 3 radians right to here, and then that little sliver right there represents the 0.1415 forever. So radians and these numbers that we were talking about are all related. So this pi that we're talking about is indeed a radian measure. Halfway across the circle is pi radians. So this arc, this length, not only is this length pi, but this central angle in radians is pi. They are the same. So what a radian measure does is it changes degree measurements to real number measurements that can be graphed easily on a number line. Degrees would be difficult to graph on a number line, but radians are much easier to graph on them because they just represent lengths, which is real numbers. And this one over here, 2 pi, there's 1, 2, 3, 4, 5, 6, and then this little sliver right here that's left over is the 0.28 part. So because of all that, this is why we want to switch to radian measurements for our certain functions that are coming down the line a little bit later. So part of what we have to be able to do is convert from degrees to radians. So how many degrees and radians are in one revolution? So one time around the circle, well, there's 360 degrees, and that is equal to 2 pi radians. If I use this and reduce it down because they both are divisible by 2, I get the conversion of 180 degrees equals pi radians. This is the conversion you will use to convert between radians and degrees. So for example, I'll just pick one of the ones that we had. Let's do 60 degrees. I want to convert 60 degrees to a radian measure. And so I'm going to use this conversion. Conversion is basically like if I have, there's 12 inches in a foot, things like that, 3 feet in a yard, and there's 180 degrees in pi. So if I want radians, I want pi. Radians is my final answer, so that would be the pi will go on top, the 180 degrees on the bottom. Remember, you want to be able to cancel your units. So degrees kind of cancel out, and you're left with 60 pi over 180, and you must reduce your fractions, and you'll get pi over 3. So that's how you can kind of use the conversion factor to change between degrees and radians. I'll show you another example a little bit later. So the next thing you're going to have to do is to find the arc length with our newfound information. That means we're going to be asked to find this length on a circle right here, given certain information. And so I'll start with the radian one. What if the central angle is given to us in radians? And this is probably the most important formula that you're going to use because we're going to use it many different ways later on. And so this arc length S is simply equal to the radius times the central angle, as long as theta is in radians. So that's a little must here, part of our little thing. Theta must be in radians. You cannot use degrees in this formula. Okay? If you have degrees, then you would basically have to change it to radians first. And so part of the formula in degrees is just you changing the angle in degrees to a radian. So it's literally going to be that kind of a thing. You're going to get whatever angle I give you. So your arc length is going to be R times your angle in degrees times pi over 180. See, you're converting it in the formula. So we usually don't do this one. It's better to just know that this angle must always be in radians. And so if it is not given in radians, change it to radians, and then use this formula over here. Because this formula will be used exclusively later on. We don't really do that one. We just do conversions. The next thing down here is the area of a sector. It's kind of hard to see in this one, but this is a shaded region. You see this question pop up a lot in standardized tests and things like that. And so how does this work? Well, we're taking a portion of the entire area of a circle. The area of a circle is pi r squared. Whether in degrees or radians, pi r squared, that is the formula for the area of a circle. If your angle is in degrees, then what percent or what portion of that degrees, this angle, is the entire circle? So that's what you see over here. You see this ratio. That's all this is on here is a ratio. So if the angle is in degrees, what is the ratio of the circle I have? And then times that by the area. And if I'm in radians, then I use this one with the 2 pi on the bottom. Find the ratio or the part that I have, the fraction that I have, and then times that by the area. So these are the two formulas you're going to be using for area of a sector. And that's pretty much it on the concept here. So we got the new measuring tool, which is the radian measure for central angles or angles in general. All of these things we found over here was the conversions. We did it already. So 60 degrees is actually pi over 3 radians. 90 degrees is pi over 2 radians. And so you're going to want to be part of kind of learning those because you're going to use those quite a lot. So let's go do some examples real quick. And if we look at our next page, we have all these kind of problems we can look at. and we can walk through real quickly. So how do I change from angles, degrees to radians, or radians to degrees? Now, how do I even know if I have a radian or a degree? This is very important, because even though this looks like it could be a radian, if I put a degree symbol on it, then it means degrees. If I don't have a degree symbol, then it means radians. So it is vital that you understand that if you're going to write a degree angle, you must put the degree symbol on there. 135 without the degree symbol is a radian. If you want to mean degrees, you have to put the degree symbol. Okay? If there is no degree symbol, then it's a radian. That's important to remember. You might want to write that down. So 135 degrees changed to a radian. I'm going to convert it by multiplying by the conversion factor, pi over 180. I know to put 180 in the bottom because I got to get rid of the degree, so they're going to basically cross out. You're going to reduce and multiply this out over 180. And when you do, I think 45 goes into both of these, and you're going to get 3 pi over 4. So 135 degrees is 3 pi divided by 4. What about radians to degrees? 11 pi over 6. The conversion now is I want the pi to drop out, so it's going to be pi on the bottom and 180 on top. And so I want my degrees on top because I want to get an answer in degrees. So we can see that the pi's drop out. 6 goes into 180 30 times. Multiplying straight across gives me 330 degrees. So that's how I use the conversion formulas. You want to make sure you practice that. Okay? So this is the arc length. Both of these problems are arc length. Write the formula that you're going to use now. S is R times theta, where theta is in radians. This problem is not in radians, so I'm going to convert 225 degrees to radians. Okay, and we work that out and reduce it out. And we get 5 pi over 4. So that is the radian I'm going to use in this formula. So my arc length is 7 times 5 pi over 4. And you just simply multiply that out, and you get 35 pi divided by 4. And because this is a measurement, you need to put proper units, and your answer will be in kilometers. And that's how you do it, and that's how you show it. This is what I'm going to be looking for when I see this on a test. This one over here, arc length, it's already a central angle in radians. So my arc length is going to be 11 times 2 pi over 3. And multiply and reduce, 22 pi divided by 3. And the measurement is in meters. That's simple. Okay. The arc length down here, we have pi r squared and then a portion. 45 degrees is what percent or what fraction of the whole circle. That's what we have there. And then we're going to times this by pi and then r squared. Just putting it right into the formula. This is my area. And we just work this out. You can use a calculator and get the proper answer for that one. And I'll just go ahead and show you how to do that. And so you have pretty much 45 divided by 360 times, and pi is down here, times pi. Also, that button down here with the pi on it, and with feature used for the calculator, that is also where theta is. You can type in the theta there too. Okay, so there's your pi times, and then 13 squared, and then you hit control, actually just hit enter, and it gives me a fraction of 169 pi over 8. And so that is my area. Areas are in square units. I have feet, so this is going to be square feet. And there's that. Okay. This one is already a fraction. It's in radian form. Same process. This time I'm just going to use 19 pi over 12. divided by 2 pi, because that's the ratio of the total circle I have. And then here's pi, and then r squared. So we got to work this out. And remember, this is a fraction divided by a fraction. So you flip the bottom and multiply, and what you end up with is 19 pi over 12 times, and then 1 over 2 pi. That's what that becomes in there, and we can work that out, simplify it. And then pi times 25. So the pi's drop out. I get 19 over 24. Okay, and so 19 times 25 is 475. So this is 475 pi over 24. That is the area of this sector, and we're in square kilometers. Square kilometers. And so that is how you do these problems and how you display your work for these problems for the test purposes.